Hello students, today we are going to understand what is 3D viewing. Now before understanding 3D viewing, it is important that you understand what 2D viewing is. Okay, because if you don't understand what is a window and a viewport, it will be difficult for you to understand the same concepts in 3D viewing. Okay, now in two-dimensional graphic applications, viewing operations transfer positions from the world coordinate plane to pixel positions in the plane of the output device. That is what happens in 2D viewing. Now using the rectangular boundaries for the world coordinate window and the device viewport, a 2D package maps the world scene to the device coordinates and the clip seen against the four boundaries of the viewport. So that is, it's a pretty simple procedure in 2D viewing, but it is not the same in 3D viewing. It's a little different in 3D viewing. It deals with how a 3D object that we see in our day-to-day life is transformed and it is displayed on a 2D surface or a 2D display device, be it a monitor, a television, anything. Okay, so we have more choices as to how views are generated in 3D. First of all, we can view an object from any spatial position. It could be from the front or from above or from behind, or you could be standing in the middle of the building and seeing what is inside, or you could be standing in the middle of a theme park to see how the theme park looks from the inside or how the zoo looks from the inside. Okay, and additionally, a three-dimensional description of objects must be projected onto a flat viewing surface. So the challenge is to project a 3D object onto a 2D viewing surface. Okay, so this is the introduction of 2D viewing. Next we are going to see a very important concept in 3D viewing, that is the viewing pipeline. Okay, now it's a 3D viewing pipeline. It is similar to a 2D viewing pipeline which we had studied in 2D viewing. Okay, now the steps for computer generation of a view of a 3D scene are somewhat similar to taking a photograph, to clicking a photograph. Now we are going to see a very detailed example when we are doing the 3D viewing pipeline in detail. To take a snapshot, what do? We first need a position. Need to position the camera at a particular point in space. Then what do? Then we decide on the orientation of the camera. Then we snap the shutter. The scene is cropped to the size of the window of the camera and the light from the visible surface is projected onto the camera film. Okay. Now this is this analogy that we are using can be carried only to some extent when it comes to 3D viewing. Okay, but we have more flexibility in terms of like the graphic packages that are available. There is more flexibility when it comes to 3D viewing. Okay, now let's see how a 3D viewing pipeline looks like. Okay, now this is a 3D viewing pipeline. You have the modeling coordinate first. You have the modeling coordinates first. Then you have modeling transformation, then you have world coordinates, then you have viewing transformation, then you have viewing coordinates, then projection transformation, projection coordinates, workstation or viewport transformation, and finally you get the device coordinates. Okay. So imagine or think of a scenario when you go to a zoo and you are looking at a caged tiger. Okay, now you want to take a photograph in that particular, you want to take a photograph of yourself with the tiger and the surrounding in the background. So that's what you want. Now let's take this as an example and see one by one what these things mean. Okay, now let's see what modeling coordinates mean. You decide, so modeling coordinate is you have seen the tiger and you have decided that you want to be photographed with the tiger. So you and the tiger and the surroundings are the object. You become the 3D object that is to be photographed. Okay, so that is your modeling coordinates. Okay, so the tiger in the zoo, you and the surroundings, you are the object that is to be photographed. So you are deciding on the modeling coordinates and you want your photo with that tiger in the background, so you know where you have to stand. So you have decided where you are going to stand, plus you know that you want to take a photograph with the tiger. So that is modeling coordinates. Next is modeling transformation. Okay, now you also have to decide which is a good angle for the photo, where you want to stand, whether the entire tiger will be seen in the background. You have to take that decision. Okay, deciding how much to zoom in or zoom, you will be having somebody who will accompany you and somebody who's going to take the photograph for you. So how the photographer will have to decide how much is to be zoomed in or zoomed out in order to take a good picture. Okay, deciding the dimensions of how much of the scene to capture in the photo. So you decide how to click based on the direction of the light, or you know, where you are standing, etc. So that is your modeling transformation. Next we see the world coordinates. Now the world coordinates, in order to fit in the photo frame, in order to fit in the frame of the photo, you decide to either stand, or you decide to lean, or you decide to sit, or you kneel down, so that the tiger is visible completely. Like you want yourself or as well as the tiger to be visible completely inside the photo. So you decide how you're going to stand, where you're going to stand, okay, so that the camera covers the tiger, you, the background, etc, etc. So this is what you do in the world coordinates. Next is the viewing transformation. Now the photographer who's photographing you will set up the tripod, he will keep the camera over there, okay, he will set up the tripod in such a way that the proper scene could be taken into the photograph, okay. Setting the camera so that the best picture will be taken with you, the tiger, and the background, of course. Now basically setting, what happens in this viewing transformation is he's setting the position and the orientation for the camera, okay. So this is called as viewing transformation. Now what happens is, next we move on to getting the viewing coordinates. How do you get the viewing coordinates? Now imagine the screen of the camera, it is also called as the view plane, okay, it is also called as the view plane of the camera. Within the window of the camera, it depends on the size of the lens. So if you are supposing 5 feet tall, okay, if you're 5 feet tall and the camera captures you, now the photograph doesn't have to be of 5, photograph is not going to be 5 feet long. What you the world coordinates, or how your size or length is in your world coordinates, and how it looks on the camera, or how it is scaled up or down inside the camera, is completely different, okay. So the camera decides the viewing coordinates of the picture that it takes, okay. That is, you can also call it as the camera coordinates or the camera window coordinates. Now this is what happens in your viewing coordinates. It decides how much of the area is to be captured, you, the tiger, the background, etc, etc, what length or how much of the area will be captured, that is viewing coordinates. How much of the photo can, like how much of the surrounding can be captured in a single photo, is determined by the viewing coordinates. That that particular window is determined by the viewing coordinates. You get the window coordinates inside these viewing coordinates. Next we have the projection transformation. Now what you're doing is, or what the photographer rather is doing is, he's adjusting the lens to focus on the objects in the photograph. What are the important objects in the photographs? It's the tiger and you, okay. So the photographer has to adjust the lens in such a way that you and the tiger and the background is to be seen properly. So that's like moving the lens or focusing the lens in such a way that you and the tiger is viewed properly. It also depends on the direction of the light. That is very important when you when it comes to taking photographs. So it also depends on the direction of the light, and the photographer will adjust the camera in such a way that he takes a good picture, okay. So that happens in your projection transformation. So that is what we do in projection transformation. Next is projection coordinates. Now the camera will decide the actual projection coordinates. It will decide the actual coordinates of the particular picture, or the boundary to click the picture. So that happens in your projection coordinates. Next is your workstation transformation. It is also called as the viewport transformation. Now the cameraman has pressed the click button on the camera and the photo has been clicked, okay. Now this is now this photo that has been clicked, now when the cameraman will view the photo in his particular display screen, or if the photo is taken through a mobile, then the cameraman will view the photo in that particular gallery, in the photo gallery. Okay, that is where your device coordinates will come into picture. The cameraman will see this picture in the camera on the mobile phone, and it will be in terms of device coordinates. Okay, so this was the example for this 3D viewing pipeline. So this is a step-by-step procedure, and it is extremely important when it comes to 3D viewing, and this perspective is very important when you are actually doing animation projects, or when you're actually making an animation video. Okay, so this was all about 3D viewing pipeline. Next, in the next video, we will be seeing the various types of 3D projections. Okay, if you have any doubts, you can ask me anytime. Thank you.